So now we're going to talk about reflexes. So these are fast, involuntary, stereotyped responses. So fast and involuntary means that they're going to happen very quickly and you don't have a choice. You're going to do this not because you're consciously thinking about it, but because this is just how your body responds. Stereotyped, think about what a stereotype means. Do you get stereotyped for specific reasons? So stereotyped is going to, in anatomy, mean that it occurs the same way every time. So when you put your hand on a hot stove, you jerk your hand away very quickly, the same way every time. It does require stimulation, so it's going to require some sort of stimulus. So in that example, the very hot stove sending impulses to your skin saying, I'm burning. So skeletal muscle reflexes are called somatic reflexes. There's two different types of reflexes, and we're going to talk about ones using skeletal muscles right now, and then we'll talk about reflexes deeper in your body later on. So a reflex arc has the same 5 nerves in order here, and so you should be able, in an essay, for example, to explain a reflex arc. So it's going to start, number 1, with some sort of somatic receptor. So here's my number 1 right here. So what's happening here, so this would be like when you go to the doctor and they sit you on the table and then they hit you in the knee with the hammer and it causes your leg to kick. So the first stimulus is going to be this tendon. Is when it gets hit with the hammer, it stretches. So common is that stretching a muscle or tendon is going to be the signal that starts a reflex. So there's number 1. And then we have an afferent nerve. Remember, A comes first in the alphabet. E comes later. So an afferent nerve sends the sensory information to the spinal cord. There's an integration center inside of the spinal cord. So somewhere in this synapse, there's integration. The spinal cord is now sending out a signal. It's receiving the signal, it's processing it, and then it's going to signal a response. Then there's going to be an efferent neuron, number 4, so this is 3. This is going to send the outgoing signal down that ventral anterior horn route out to the muscle. And then number 5 is there's going to be an effector. So the effector is going to cause an effect. That's why it's called an effector. And that's going to be, in this case, that's going to be these quadriceps muscles. So you can see the rectus femoris and the vastus lateralis here, which are going to contract and cause the leg to kick out. So the essence of a stretch stimulus is to have a stretch receptor. And in the muscle, a stretch receptor is called a muscle spindle. There are 2 different types of motor neurons here. So remember, a motor neuron is just a nerve that's going to send information to a muscle, right? This is going to happen at a neuromuscular junction. So there's 2 types. There's alpha, this is a Greek letter alpha, and then there's gamma, so that's gamma. This is the actual muscle spindle here inside of here. So that you can see that it's wrapped up in this tissue. So in this picture, they've kind of unwrapped it from the capsule. And then out here, we've just got the normal sarcomeres. So if this is the quadriceps muscle from the last picture where we just saw it contracting, the alpha motor neuron, these are the ones you already know. These are going to send signals to the regular muscle fibers. The gamma motor neuron is going to go to what are called the intrafusal fibers. So those are the ones in here, intrafusal. Intra means inside. So they're inside of the spindle. And these are going to give information about stretch. So we have nerve endings in here, sensory nerve endings, that are going to receive stretch information. So this is how our muscles know when they've been stretched. So here's that stretch reflex. So we can walk through this again, and it's been broken down into a little bit more detail here. So here's our patella tendon, And when this happens, the tendon goes from straight to bent in a little bit. So this gets stretched. So that's going to signal the muscle spindle. So the tendon is going to pull on the muscle. The muscle spindle is inside of those intrafusal muscle fibers. And that's going to send a signal up the afferent neuron to say this was stretched. So that goes up to the spinal cord, where it's going to interact with some primary motor neurons, and then eventually send a motor response through an alpha motor neuron to two different muscles. It actually sends to the quadriceps to contract, and then it inhibits the hamstrings down here so that these are relaxed. So this image, you can see two different reflexes that happen at the same time. So we've got the withdrawal reflex, which is common if you ever stepped on something sharp. So you can see this person is walking in the ocean and steps on broken glass, which I hope that you would wear shoes if you're in an ocean with broken glass in it. But this might happen if you've got like a tack or something in your shoe, or you step on a staple or a pin or something hard or sharp. And so you step on something and you would immediately withdraw that foot. And so that's the withdrawal reflex. But when you do that, you're taking all of the weight off of that foot. So like if I step on this glass with my right foot, that means I'm going to put all of my weight here on my left foot. So at the same time, you're also going to stimulate another reflex called the cross extension reflex. That's going to lock that left foot in place to make sure that you're not going to just also fall over. So you can see that these are both started by the same stimulus. So here's my stimulus. It's going to send a signal up my afferent nerve to the spinal cord. And you can see the integration here in purple is much more complex. And it's actually going to decuss. It's going to cross the spinal cord. So on the same side, it's going to send a signal to the quadriceps to pull the leg back up, because we don't want to be stepping on whatever that sharp thing is. And at the same time, it's going to send a signal to the opposite leg to extend the leg to contract, so that the body is stable and this guy doesn't fall down and, hurt himself on more broken glass in this very polluted water. The last reflex we'll talk about here is called the tendon reflex. So this is the tendon of the muscle attached to the femur here. And the tendon organ is a proprioceptor. So this is a sensory organ that tells the body about where itself is. Proprioception is kind of when you close your eyes, how you can tell where your arms and legs are. And so this reflex inhibits alpha motor neurons, and these are the ones that cause muscle contraction. So what this is going to do is it's going to stop the muscle from contracting by inhibiting these neurons. And that actually is going to help to prevent these tendons from tearing. So what happens is when this tendon organ feels that it's being stretched, it will actually send signals to the muscles to inhibit it. So minus signs, inhibit. So that this isn't stretched too far, and that's going to help to prevent the tendons from getting damaged or torn. So take a moment and describe the 5 steps involved in a generic reflex arc.